Hello pre-calc people, welcome to chapter 7, which is some more trig. In this chapter we're going to do a lot of your trigonometric identities. My favorite thing is solving trig identities or doing the trig identities. So let's start off with some of the most basic properties. We're going to start off with your reciprocal identities. So remember that the sine of x, its reciprocal is 1 over cosecant x, and correspondingly, if I had cosecant x, I could replace it with 1 over sine x. And that's kind of why we're going through this, because you use substitution on using these properties. So cosine is 1 over secant x, and then its reciprocal, secant, is going to be 1 over cosine. And then our last one is going to be tangent, and its reciprocal is cotangent. So we know that cotangent has tangent as its reciprocal. Now, what is the reciprocal? The reciprocal is actually the opposite in the hypotenuse or the opposite in the adjacent. It's the sides of the triangle, the ratio of those sides that you're doing a reciprocal of. So if I had secant theta is 3 over 2, I know cosine theta is 2 over 3. Because remember, this is the hypotenuse over the adjacent, and cosine is the adjacent over the hypotenuse. So it's the ratio of the sides that represents that reciprocal. Then tangent, we know, is y over x, and on that unit circle, the x is usually goes with your cosine, y goes with your sine. I'll keep it as theta, which means then I have, let me see if I can scrunch this over a little. So I know that the ratio of tangent is going to be y sine theta over cosine theta. And if you were to use your reciprocal functions, so we know then the way you would use it, the reciprocal of sine is cosecant, so that means cosecant now will be in the denominator. Cosine, the reciprocal is secant, so that would go in the numerator. That's how you can use those reciprocal functions. And then for cotangent, we know it's going to be the reciprocal, so it's x over y, so cosine over sine. And again, if I wanted to use my reciprocal properties to rewrite that, sine, now cosecant would come upstairs and cosine. So again, these are setting up what we can use as substitution when we are proving our identities. So here we have our first little example of that. Simplify each expression. So we have sine squared and then tangent squared. Well, there's not much I can do with sine squared, so I'm just going to rewrite it as is. But tangent squared, I can bring it upstairs, so I don't have a fraction, as cotangent. That's what a reciprocal means. Basically, you're going to the other side of the fraction bar. So that would be the first step. The second step then would be, again, there's nothing I can do to break down sine, but I can break down cotangent using what we just went over. We know that cotangent in terms of cosine and sine is cosine squared over sine squared, which is nice because then my sine squareds cancel, and your final answer is cosine squared theta. And that would be considered as simplified as you could get. On this next one, we have sine theta plus cosine cotangent. So I find a lot of times people like to break everything into sine and cosine. And also I will give you a little strategy. Anytime you're adding two, you at some point may want to find a common denominator. So my first step though is to write everything as cosine and sine. So cotangent again is cosine theta over sine theta. So notice I'm adding two things that do not have the same denominator. So what I'm going to do is I am going to multiply this one top and bottom. So multiplying the top by sign makes that squared. This would be multiplying the bottom. Now I can start to simplify this. So what I really have here is sine squared theta plus cosine squared theta over sine theta, and I know we're getting a little bit ahead of ourselves, but this is not your first time at the rodeo. So sine squared plus cosine squared, as you're going to be reminded in a minute, is 1 over sine theta. Now that's not considered completely simplified because it's a ratio, so we want to write this in simplified form. That would be cosecant theta, and then we're done. All right, so I know I kind of jumped ahead there with the Pythagorean, so let's reintroduce it. So we know that in a unit circle, x squared plus y squared equals 1, because the unit circle has a radius, and this always represents the radius here. And if cos x is again our cosine and y is our sine, we can then substitute to get cosine squared plus sine squared equals 1. Now, why do I have these three boxes? Because I want you to get used to the fact, especially when you're doing the trig identities, it's not always going to come to you as cosine squared or sine squared. So you have to get comfortable isolating one of those. So if I isolate my cosine squared, this is equivalent to 1 minus sine squared. If I isolate my sine squared, then this equals 1 minus cosine squared. So when I'm doing an identity, anytime I see something squared and a 1, I look to see if it goes with one of my Pythagorean identities. Now, we are going to ask you then to derive. There are two more, and it's really easy to derive the other two. So this first one, so I have them written down here below. We have cosine squared plus sine squared equals 1. I'm going to divide every single term by cosine squared. Cosine squared, cosine squared. So when you simplify this out, you get 1 plus sine squared over cosine squared is tangent squared, and that equals 1 over cosine squared, which is secant squared. So we have the identity that 1 plus tangent squared theta equals secant squared theta. And again, it won't always come to you like that. So let's isolate each of the other two variables. If I isolate 1, this becomes secant squared minus tangent squared. And if I isolate the tangent squared, then we're going to get secant squared minus 1. So you want to get comfortable seeing them in their different sort of iterations. Now this last one here is, so the first one we divided everything by cosine. Now we're going to divide everything by sine. So as I go through, and this is really all the amount of work you need to show, and then simplify. So cosine over sine now is cotangent squared plus 1 equals 1 over sine squared, which is cosecant squared. And that gives us our third Pythagorean identity. So this is, I can never seem to write cosecant squared correctly. All right, so that would be that. And once again, we want to isolate each variable separately so we get used to the different iterations of this. So this would be cosecant squared minus cotangent squared. And then if I isolate cotangent squared, I get cosecant squared minus 1. So the reality is I only ever really memorize, if that's what you're going to do, this one, because the other two are really easy and quick to derive. So at most, try and at least remember cosine squared plus sine squared is 1, and realize you can either divide by cosine squared or you can divide by sine squared to get the others. All right, so let's do two little simplifications. I actually find simplifying is a little bit harder than prove an identity because they don't tell you what your final answer should be. It's kind of up to you to know when it's as simplified as possible. So this first one, sine x plus sine x cotangent x, very similar to one we just did, but not quite. So let's see how we can do this. There is a plus. A plus a lot of times means either a common denominator, or the other thing you always want to look for is, do you have a GCF? Do you have something in common? So if I have something in common, I can pull that out. So this, don't forget that there's a placeholder of 1 plus cotangent squared x. It's always a good rule when you factor something out, just take a look at it and make sure if you distributed back through, you'd get back your original, which we would. All right, so this is nice. I have sine x here. I can now, I see something squared with a 1, so I kind of go back and I look at my identities and I see, oh, look at that. This can be substituted with cosecant squared x because that's that Pythagorean identity. And now it's up to you what your comfort level is. Some of you might like to take the step where we rewrite cosecant as 1 over sine squared. Use your reciprocal property. So this sign will cancel with that sign. So what do I have? I have 1 over sine, and 1 over sine is that. My two little lines always means I'm done. I am done. All right, so that was utilizing your Pythagorean identities. Now, let's do the second one, cosecant minus cosine. And I would recommend, if you like, turn off the video for a second or pause it and try this on your own and then come back. All right. So I'm going to use a strategy I know you guys often like to use, is I'm going to turn everything into sine and cosine. So 1 over cosecant is going to be 1 over sine x minus cosine will stay on top. Nothing I can do with that. Cotangent is cosine over sine. So that's nice. I have a common denominator. So I can write this as one fraction, 1 minus cosine squared x all over a common denominator. And again, I see something squared in a 1, so I go look at my identities. Do I see a 1 minus cosine squared? Yes, I do. And so that's going to turn into, not what I was about to write, that is going to turn into sine squared x, and I still have sine in my denominator. So now we have this will cancel with that, and the final answer is just sine x. All right, fun stuff. So have fun with that.